السلام عليكم. يعطيكم العافية شباب. احنا هنبدأ اليوم في موضوع جديد ندخل فيه شوية ستاتيكا مع ميكانيكا مع strength of materials كل هذا الكلام. فالموضوع بيحتاج لتركيز شوي، لكنه هو أساس حقيقة، هو أساس الميكانيكا التربة. واضح؟ هو أساس ميكانيكا التربة. موضوعنا هو stresses in soil. stresses in soil. ستريس نرمز له ستريس سيجما، رايت؟ شو بيساوي الستريس عادة؟ بيساوي P على A، يعني load over area of application, right? Load over area of application. Good. So if we have, for example, soil like this is a soil layer which has gamma unit weight, okay? Gamma. At depth equals to H point A, okay? Point A. At depth H. What will be this is point A, okay? What will be sigma? Gamma في H. Gamma في H. Unit weight multiplied by the height. Okay? Because the stress is the weight of the of all what we have above that point. Okay? And what we have here is soil. Okay? With a unit weight of gamma. So the height of the soil H multiplied by gamma, the unit weight of the soil, it will give us sigma. Right? If we have different soil layers, for example, like in this case, I have H1 gamma 1, H2 gamma 2, Z gamma 3, then at point A, sigma equals gamma 1 multiplied by H1, gamma 2 multiplied by H2, gamma 3 multiplied by H3 or Z, whatever. Let us call it H3. Right? Okay? So if we have different layers, every layer multiplied by its unit weight, because they are different in their unit weights. We cannot consider them one layer. Okay? What if we have this case? This symbol is for water. It means that I have a water. Okay? This is water, just water. So what will be at point A sigma? H1 or H multiplied by gamma water, right? H multiplied by gamma water, which we know. We know how much is gamma water, right? Okay, suppose we have this case. Okay? Now, this is H1 gamma 1, H2 gamma 2, H3 H3 gamma 3, Z gamma 4, right? At point A, sigma will be how much? Now remember, we have water here, right? So what it will be? H1 multiplied by gamma 1. What is gamma 1 here? It's gamma dry, remember, right? It's gamma dry. H2 plus H2 multiplied by gamma 2, which is dry. Then H3 plus H3 multiplied by gamma 3, but this gamma is gamma saturated. Gamma saturated, because this is not water. This is the soil plus water. That was water alone. Here we have soil plus water, then it's soil, saturated soil. Then this must be gamma saturated. Then Z multiplied by gamma saturated 4. So it's like this. Gamma 1 multiplied by H1 gamma dry. Gamma 2 multiplied by H2 dry. Then gamma saturated for 3 multiplied by H3. Then plus Z gamma saturated 4, right? Right? So we have always to multiply the height by the unit weight. But which unit weight? The unit weight that is corresponding to the situation. If we have dry, then it is gamma dry. If we have saturated, if it is weight, and we know all of them, right? Gamma weight, gamma saturated, gamma dry, right? Guys, I can give you a question and I will not give you gamma. I may give you EWG, for example. You have to calculate gamma, right? I will not tell you, but you should know that here you have to find gamma dry. So you go to the column where gamma dry, you remember? And you calculate gamma dry here. And here you calculate gamma dry. But here you calculate gamma saturated. Here you calculate gamma saturated. You may make mistakes here, right? Remember, anything above the water level will be dry. Anything below the water level will be saturated. So you should calculate gamma dry here, gamma saturated here, gamma saturated here. But if I gave you gamma, don't ask me this is saturated or not. Of course it should be saturated, okay? Without telling you, it should be saturated. I gave you a gamma saturated. I gave you gamma dry. Okay? You put this in your mind. And now we go to the most important thing. Now, if we have this condition, okay, this condition says that I have water above soil, okay, water above soil. The height of water is H1, and the height of soil is, the height of this point in soil is HA. This is point A, right? So what I have is soil, and above the soil I have water, H1. It's like a lake, okay, or whatever, basin, whatever. I have soil, above the soil I have water, okay? The height of water is H1. I took a point there in the soil, any point. I took the point A, which is at HA from the surface, okay? If I want to calculate the sigma at A, it's obvious. How much sigma at A? It's H1 multiplied by gamma water, right? H1 multiplied by gamma water. Okay, let me just be consistent with the book, so I will omit this. Okay, this is H. I don't need to have H1, just H. Okay, so it will be H multiplied by gamma water, right? H multiplied by gamma water. That will give me the stress from the water, plus HA minus H, which is the height of the soil, right? HA minus H multiplied by gamma saturated, right? I didn't do anything new. All of these things, you know. Okay? It's always, I have to find the height of the soil or the water or whatever above that point and calculate the weight of that load. The weight will be the height multiplied by unit weight. That's what I'm doing. Okay? So here, for example, in this case, the stress from water will be H multiplied by gamma water. Then the stress of this soil will be the height of this soil, which is HA minus H multiplied by gamma saturated, because water cannot go above unless it is filling all the voids down, right? So it should be gamma saturated. So I end up with this equation. Stress equals to H multiplied by gamma water plus HA minus H multiplied by gamma saturated. Okay? Now, in 1925, almost 100 years ago, okay, there was a person. I told you that there are very important 5 names you should remember, right? Remember that? Number 2 is Darcy. Number 3, secret. Number 4, later I will tell you. Number 5, Your own name. Remember, right? What about number 1? Number 1 is Terzaghi. Karl Terzaghi. Karl Terzaghi. They call him the father of soil mechanics. The father of soil mechanics. Karl Terzaghi. In 1925, he made a revolution without blood. Okay? A revolution in our understanding of soil. Okay? He said, if we put a load on the soil, and that soil is saturated, as we discussed here. You see? This is the soil, saturated soil, right? Now, when we put a load here, and we found how much is sigma, stress sigma equals how much? The water plus the soil, the saturated soil. He says that this is wrong. This is wrong. When we put load on submerged, saturated soil, you know submerged, saturated, okay? If we put load on the soil, saturated soil, we thought that it will be held, all this load will be held by the soil and water, right? He said, no, this is wrong. It's not like this. So, how it is? It will be like this. Here we have the at the first incremental time, at the first increment of time, at the very beginning of load application, all load will be carried by water. Okay? By water. All load will be carried by water. And zero load will be carried by soil. And immediately, water will lose some of his ability to hold the load, and it will be given to the soil. So as you see, water will be decreasing as much as the soil will be increasing, right? Until we end up after, I don't know how much, 10 years, 200 years, 2,000 years, 2 minutes, whatever, depends on the soil. But at the end, I will end up with water holding nothing and soil holding everything. Okay? So if this is sigma max, then this is 0, right? This is 0, this is sigma max. But at any time, both of them will be sigma max at any time, right? Because sigma max plus 0, sigma max. Whatever we lost here, we added it here, right? So this plus this will so it will be constant. It will be constant, okay? So this idea, it was called the effective stress concept. That's the revolution that Terzaghi did. He gave us a new terminology. What it is? What is that terminology? It's effective stress concept. He says that when we put any load, it will not be taken completely by the soil. Partially by the soil it will be taken. Part of it will be taken by water, okay? And this part is changing, right? So at any time, soil will take this much, while water will take this much, okay? Listen, look at me. At any time, it's almost that the amount of load that is taken by the soil is always less than the maximum, right? Only at the end it will be the maximum. So it's between 0 and the maximum. So if it will take 2,000 years, and we just began 100 years ago, so now we are taking less than the maximum, right? So if we are taking this less than the maximum, Why to deal with this amount, sigma maximum, while in fact the soil is just holding this amount? Okay? Anything will be, this will be waste, right? This will be waste. So it is important to calculate at any time how much is the stress held by the soil itself, because it's always less than the maximum stress. This is the idea of Terzaghi. Okay? And we need, first of all, to understand it, then to prove it. If he is right or wrong, we should prove it, if he is right or wrong. Okay? Now, so Terzaghi, then, Karl Terzaghi, who's from Hungary, he offered for us effective stress concept. In brief, he said that the total stress equals to two parts of stresses. One carried by soil and the other is carried by water. Right? Instead of dealing with one stress, he divided it to two parts. One by soil, one by water. Okay? Because at one time, most of the stress is held by water and less is held by soil, right? And some other times it's the opposite, as we saw now in the drawing I draw. Okay? What does it mean? It means that effective stress concept says sigma total, whether I wrote it sub T or without sub T, okay? Sigma is total, equals to sigma prime, you see, sigma prime, this is held by soil, plus U, this is held by water. Or I can write it sigma prime equals to sigma total, sigma minus U, right? So this is important. Sigma prime equals sigma minus U. Now, what are these? Sigma total, whether I wrote it sub T or without sub T, is total stress. What it is? It is the stress from soil and water. The stress from soil and water. It will be equal to effective stress, sigma prime, effective stress, which is stress from soil submerged in water only. Stress from soil submerged in water only. And U, what is U? Stress. Actually, I have to write it sigma W, right? But we will use this abbreviation, this symbol, U. U, and by the way, U small. You don't need to write it U big. U small. It's stress held by water only. And from now on, we will call it poor water pressure. Poor water pressure. Okay? So, I can translate this to be effective stress equals to total stress minus poor water pressure. Okay? Effective stress equals to total stress minus poor water pressure. Total stress equals to effective stress plus poor water pressure. Effective stress is the stress carried by soil submerged in water only, by soil only. Poor water pressure, stress carried by water only. Total stress carried by soil and water. Until now, we were dealing with total stress, right? Now, remember the drawing I just drew before, and we calculated for it, the water above the soil. We calculated sigma total. Now, Terzaghi says, don't do that. Calculate effective. We need to deal with the effective. Is he right? Is he right? Let us prove this. Before that, let us apply this here. You see, as we see here, this is H, remember? And this is, we call it HA, right? And we found that sigma total equals to H multiplied by gamma water, right? Plus HA minus H multiplied by gamma saturated, right? We did so, right? H multiplied by gamma water plus this portion, which is HA minus H multiplied by gamma saturated. This is sigma total, which we will not deal with it from now on, if we prove that Terzaghi is correct. Okay? This is sigma total. Now, if we apply the equation sigma total equals sigma minus plus u, right? Which means that, sorry, sigma effective. Sigma effective equals to sigma minus u, right? Total minus pure water pressure. Let us find what is pure water pressure. Pure water pressure is the height of the water above the point multiplied by gamma water. Whether there was soil, whether there was no soil, whatever, I don't care. It's the height of the water above that point. So, U, the height of water above this point, whether there was soil or not. How much is the water above this point? HA. You see? HA multiplied by gamma water. You see? Sigma, which is sigma total, equals to H multiplied by gamma water plus HA minus H multiplied by gamma saturated total. ايش هو؟ U full water pressure. دائما ارتفاع عمود الماء فوق النقطة بغض النظر شو في عندي في الطريق. حواجز، إطارات مشتعلة، مظاهرات، ما إلي علاقة. تربة فيه، ما فيش تربة، أي حاجة ما إلي علاقة. ارتفاع الماء فوق النقطة. عشان هيك إذا بتلاحظ أخذنا ارتفاع الماء قديش فوق النقطة في مي؟ كل هذا مي فوق النقطة. ما تقول لي هون ما في مي، ما وصلت المي لفوق إلا لما كانت معبية تحت. هيك عندنا دائما تعبي عند الجيران تحتينا قبل ما تعبي عندنا. شيء؟ إذا ارتفاع عمود الماء HA multiplied by gamma water لأنه أنا بحكي عن المي، صح ولا لا؟ طيب يا شباب الآن إذا كان نقصناهم من بعض علشان نحصل الإفكتيف، مش الإفكتيف بيساوي التوتال ناقص يو. إذا we will go to this one. Sigma prime equals sigma minus u, right? Sigma, we said H gamma water plus HA minus H مضروبين في gamma saturated. هاي كلياتها خلصناها. ننقص منها HA gamma water, which is H gamma water plus H A gamma saturated minus H gamma saturated minus HA gamma water. Look, I have here gamma water, gamma saturated, and I have here H, and I have HA. So this will be HA minus H multiplied by gamma saturated minus gamma water. Sigma prime equals to sigma minus u. Sigma, total stress. H multiplied by gamma water, the weight of the water, plus the weight of the soil multiplied by gamma saturated, which is HA minus H. Okay? And we subtracted from them u, which is HA multiplied by gamma water. We ended with HA minus H multiplied by gamma saturated gamma water. Okay, let us write it again or remember it again here. Okay, so what we need is to subtract this from this. We ended up with what? HA minus H multiplied by gamma saturated minus gamma water. Now what is HA minus H? HA minus H. Height of soil, right? Height of soil. The difference between HA and H is the height of soil. Multiplied by gamma saturated minus gamma water, which is from now on we will call it gamma prime, gamma effective. Okay? What is gamma effective? What is gamma prime? It's gamma saturated minus gamma water. You should remember this. Don't ask me about it. Okay? Gamma prime, effective unit weight. Okay, how many unit weight we already have? Gamma, gamma wet, gamma moist, right? Gamma dry, gamma saturated, gamma effective, gamma prime. We still need another 8. 1, 2, 3, 4, 5, 6, and 7, 13. Good. We still have 7 to study about. No, it's just a joke. Okay. Gamma effective. Effective unit weight. What is gamma effective? It's gamma saturated minus gamma water. So, if you need to deal with gamma effective, I gave you gamma saturated, you just subtract gamma water, which you know, you will end up knowing gamma effective. Okay? So we did that. We subtracted them. So, this is what I did here. Sigma prime equals to sigma total minus U, or H gamma water plus HA minus H for gamma saturated minus HA for gamma water. And we ended up HA minus H for gamma saturated minus gamma water, or height of submerged water multiplied by gamma effective. Okay? Multiplied by gamma effective. Height of submerged water multiplied by some gamma effective. This is called gamma effective. Effective unit weight. This is called effective unit weight, right? Effective unit weight. What is effective unit weight? It's gamma saturated minus gamma water. This is, you should remember well. Okay? Gamma effective equals gamma saturated minus gamma water. This is very important. You should remember it. You should memorize it. You should know it well. Effective unit weight. Okay? We should prove that. Terzaghi says, don't use total stress, use effective stress. Don't use sigma total, use sigma prime. Okay? Remember something. It's called effective unit weight, and this is effective stress. Effective stress is height of submerged soil. Sorry. Height of submerged soil. Soil in water. So if we don't have water, we don't have effective. Okay? If we don't have soil in water, we don't have effective. Because at that time we have just dry soil. Okay? So there is no effective. If we have water only without soil, we don't have effective, because that's water stress. Okay? To have an effective stress only in one case. What is that case? We have to have water submerged in soil. If we don't have soil submerged in water, if we don't have water, then there is no effective stress. There is a dry condition. If we don't have soil, we have water stress. We don't have effective stress. To have effective stress, we have to have soil submerged in water. Okay? Now, to prove this, to prove Terzaghi's idea, if it is correct or not, we will take 3 conditions. Okay? We will take 3 conditions. The first condition, we call it no seepage condition. Don't write now. Just let me explain something. No seepage condition. What is seepage? What is seepage? Seepage means water flow. Okay? No seepage, no water flow. Seepage. You didn't take this in fluid? Seepage. تسرب الماء. تسرب الماء. تدفق الماء. تسرب. احنا بنحكي عن تسرب. No seepage. Then we have a constant here. Leakage. Leakage is something you don't like. Leakage, تسرب, but you don't like it. Leakage, something you try to prevent it, it happens, okay? Due to a problem. There is a hole in the pipe, there is a problem in the joints, So there is a leakage. You don't like leakage. But seepage, you need seepage. You may orient it only. You may direct it. Okay? It's not something happens against your will. Leakage, it happens against your will. leakage تسريب خطير ما بتحبوش انت مش عايزه. Like what we have WikiLeaks. WikiLeaks. Nobody likes it. Right? Because it speaks about something you don't like it. Okay? WikiLeaks. Leakage. Okay? But here seepage. Okay guys, what we will do? We will study 3 conditions. So we will have this drawing 3 times. That's why I don't want you to draw it now. Okay? We will draw it next time. We will need a page for it. Okay? But it's actually in this way. We will explain this later, next time. No seepage. There is no flow. As you see, it's closed here. We have water here. We have soil here. Then what will happen? Will happen that everything will remain the same, right? There is no seepage. If we open here, then there will be flow, right? So there will be flow. There will be seepage. So we will take 3 conditions. No seepage and 2 other conditions when we have seepage in both directions, in 2 directions. We will compare them to see. Terzaghi suggested to deal with effective stress. Is he correct? Was he correct? Is he correct or no? This will be explained next time.